Welcome back! In this video, we're going to talk about how we actually measure pH in the lab, and how to handle some of the more technical math problems where we have to find the pH starting from a hydroxide concentration instead of a hydrogen ion concentration. In the lab, the most accurate way to measure acidity is with a pH meter. It uses a sensitive glass probe that you submerge in your solution, and a wire sends a signal back to a digital meter. These are delicate instruments. You'll often see salt crystals on the tip because we store the probes in a potassium chloride solution to keep the membrane working correctly. If you don't need a digital reading, you can use indicator papers. These change color depending on the pH. Litmus is the most famous, but universal papers can show a whole rainbow of shades. A fun at-home version is purple cabbage juice. If you boil red cabbage, that deep purple liquid acts as a universal indicator, changing color the moment you add a drop of something acidic or basic. Now for the math. Sometimes a problem will give you the hydroxide concentration and ask for the pH. You can't just take the exponent and call it a day. That would give you the pOH, which we're not using here. Instead, you use our exponent trick to find the hydrogen ion concentration first, and then you can identify the pH. Let's look at an example. If your hydroxide concentration is 10 to the negative 5, you ask yourself, 5 plus what equals 14? The answer is 9, so your hydrogen ion concentration is 10 to the negative 9. Now that you have the hydrogen concentration, you just look at that exponent of 9. And that's your pH. Since 9 is higher than 7, we know this solution is basic. You can also work backward. If I tell you a solution has a pH of 3, you immediately know the hydrogen ion concentration is 1 times 10 to the negative 3 molar. From there, you use the same add up to 14 rule to find that the hydroxide ion concentration must be 1 times 10 to the negative 11 molar. Mastering these jumps between ions and pH is the key to this chapter. In our next video, we'll see what happens when these acids and bases actually start reacting with metals.